Okay, for this particular segment of the video, before we start CAD designing this part, let's go over CAD drawing real quick. Maybe you're applying for a patent on your big ideal. You're going to need to know how to do CAD drawings. Maybe you're a machinist and you've always wondered how to do these CAD drawings. Or maybe you're trying to just be well-rounded and understand the full process of CAD designing something to passing that design off to another party or another department that's going to use that to create a part. A lot of times when you see these drawings right here, some software makes it way too hard, and it should be a lot easier. And Autodesk is just brilliant when it comes to CAD drawing. Some of the software I've seen out there, like SolidWorks, FreeCAD, Rhino, Solid Edge, they just make CAD drawings just way too slow. And Autodesk seems to always have the flavor right when it comes to quickness and productivity. So I work for an aircraft company currently, and we'll see something like this. We'll see a CAD drawing that has GDT tolerances, maybe who it's approved by, who checks the design. When we make a part, they'll check the part against the CAD drawing, who drew the CAD drawing. Very important here, revisions, drawing numbers. Maybe we have a drawing number there. Click that little text up here, a little text option. Do a drawing number. Maybe we'll do 1, 2, 3, 4, 5. And then, every time we revise it, maybe I need to update it to revision 4. So anytime that, you see a drawing like this, it's going through a process flow. And you should see, a lot of symbols like this. Maybe you're curious what these symbols are. A lot of these symbols are going to be your dimensions, but we also have GDT symbols and things like that. Let me get rid of this part real quick, and let's bring one in. Here you see two different parts. Come up here to create the base view. Maybe I want to turn the two parts we have together, leave it. Maybe I want it to be solid. But don't worry about following along, because you're going to create this part after I cover over the CAD drawings, but it's important to see some final result. So maybe you're just wanting to learn Fusion because you want to 3D print something, and this won't be interesting to you right now. Well, I can give you a reason right now. If you learn how to make a CAD drawing and you present that to other people, first off, when you start designing stuff in Fusion, people are going to come to you and could you design me a kitchen table? If you can design it, I know how to cut the lumber and build it myself. If you can come up with a nice drawing for this, this, and this, all kinds of different things are going to be revolving around a CAD drawing. So again, this portion of the video, we are going to be jumping into actually designing this part here, but I just want to give that little bit of inspiration of why you need to learn CAD drawings, because in the aircraft industry, we have to live by them. Everything has to be designed and made to the specifications on a CAD drawing. And some of the things I see, in different environments with different CAD environments is what I would like to see, and what I would do is I would put a table up here with information. So maybe we have a part number, a work order, and a type of material like aluminum 2024 T3, 25 thousandths thickness. And I see a lot of CAD drawings that aren't they're not very standard in the sense of using nice clean tables. Instead, they'll type out the part number. They'll put all this information in here like this, and it's actually really hard to see. It's not very clear compared to how a table looks. The table's very clean. You put the same information in a table, but the table just is a kind of a nice standard for part numbers. If you have a bunch of part numbers, if this is a large assembly, you can auto generate a table. Like I click table here, click automatic. I can select this body right here, and I can put this right underneath it. It'll tell me material steel. So when we go through, the design process of this, we can always change the material type, and that way when we get to the part where we're creating this CAD drawing, it'll automatically know the material type. It'll know part number. Like uh, we can specify all this ahead of time. How many, the quantity, and we can automatically build a list at a click of a button. That's how it should be with smart software and Fusion 360. So let's go ahead and do a CAD drawing here, and then we'll get you guys jumping in to actually drawing something and making this 3D model here. I'm going to select that right there. Then I'm going to make this 4 times bigger by scaling it 4:1. Click OK. Here's the body here. So with a lot of other CAD software, you can some of them have an auto dimensioning feature, and I'm going to show you why it's nice, and I'm going to tell you why sometimes it's not so nice. So with Fusion, it's pretty much nice all the way around. Click on it. I can click, I have different ordinate dimensions, symmetric with ordinate dimensions. I have different options to generate here. If I want a different kind of profile, maybe some overall dimensions, maybe a couple chain dimensions. But real quick, or I can just do everything and then click OK. And man, if you CAD design this part after you follow along this tutorial video, and then you go create a CAD drawing and show your friends this kind of stuff, you're just gonna look really smart. But maybe you're in a tech environment or a manufacturing environment, and for you, you just want to be able to know how to do it and how it's done. And in most CAD software, it's very much the same. You design your part, and there's a drawing feature, and you can quickly import your stuff and start doing this. But Fusion does it beautifully. And when you watch this tutorial, we'll cover through creating a drawing, and it'll all make sense to you from where these parts are coming from. So again, for now, don't worry about too much about following along, because right now you haven't made this part to follow along. So for now, we're just covering this in advance, because this is very, very important. So why is auto dimensioning not always the best? Well, what we call this, in a machine shop, we would call this a lot of noise. Some of the stuff we don't really need a lot of the stuff. It can be really simplified, and it can be simplified down. So let me get rid of all that noise, and instead we can dimension things manually. Overall dimension, and boom, everything is nice and clean. But what about some GDT? We need some tolerances. Right? GDT is very simple and it's beautifully done in here. I can I can specify the property, a part number, etc., part name if there was one. In this case, we're not going to worry about that. I want to come to linear precision and go 3 decimal places after the or 3 zeros after the decimal. We'll do trailing zeros. I'm going to come to tolerance, and here's what I love about Fusion. I can do a symmetrical tolerance, and here's what I see a lot in different CAD environments. They'll have a 5,000th tolerance, right? Plus or minus 125,000 plus or minus 5,000. What does that mean? Like when maybe your machinist is tired. Maybe he had a couple beers too many the night before, and he's not all there. And now he's going to do his math in his head, which is real simple. 130 thousandths or 120 thousandths is our plus and minus tolerance. Well, Fusion's very nice in the sense that we can do deviation. And we could say plus 100,000 or 500 or 5,000ths or minus 5,000. But even nicer than that, and with a deviation, maybe we're allowed to go to 10 thousandths on the high side and 5 thousandths on the low side. So that's our floor and our ceiling of our tolerance. But what's very nice here is we could just click limit, and I could say on the high 5 thousandths, on the lowest 5,000. Now the machinist doesn't have to do any math in their head. They just know the high is 130 thousandths, the low is 120 thousandths. So after they make the part and we inspect the part, this hole should be no bigger than 130 thousandths, and it should be no smaller than 120 thousandths. We have essentially 10 thousandths of tolerance for this hole. Very simple, very clean, very to the point GDT. Then you have other features in here, like, you got a welding point. Maybe this is where a weld point's going to go. That's GDT. Flip that around. Some, different kind of GDTs. There's some kind of a taper and slope going. You have all your, you have different symbols here, and you can watch a GDT course if this one makes sense to you. Cover some of these different symbols here. A datum identifier. This might be where your machinist. Maybe this is the point of entry here. You want to. You want. Data. Say this is our C datum identifier. When we're looking at CAD drawing and we're identifying each little hole and things like that, you can easily do it in Fusion 360. It's right to the point. We can also do different kind of center lines and things like that. We can do a geometric or target, as I like to say it, right there in the middle. Your point references there. Maybe you want to do a break. Maybe we want to. Maybe this is a 15-foot long part. Maybe this is 15 foot long. It's not 1.8. We want to create a break view. Easily do that. We want to just break it there and there. And so we have a break. So instead of having a long part stretched across here, we have a break in it. Very clean, very to the point, very nice CAD drawing ability built right in the Fusion 360. So let's go ahead and jump on into the actual CAD design part. We're going to make these parts right here. But I'd like to let you know that you notice here there's two different parts here. Here's both parts put together. So over here I have another drawing of this part. We could put more information in here. We could have all the information we need and just dazzle it up with material information, and we can put more. We could throw more model views and put this orientation in 3 different ways. Maybe if you're filing for your patent, you need to show the front side, the back side, left side, right side, and you'll have a bunch of these different kind of models, spread throughout, so you have a good clear view of the design. If you go to the UPTSO patent website, I have designs that I patent, and all my CAD drawings were done in Fusion 360. I did it myself, and the attorneys used all of those. And when you do them yourself, you save tens of thousands of dollars of having somebody create them for you. Attorneys have people that they contact that will basically do this right here for you. So by learning this, you might as well just say this first session of overview could save you, 10 grand of having someone else simply do this for you. Anyhow, again, you can, select between the 2 pages, and you can export everything. If I want to export all sheets, and I save them to my computer. I want to send it off to a patent clerk or a patent attorney. Now there's my PDF. I could print it out. I can download it, or I can print it out and email it all as one file. So now my patented design is getting sent to the patent attorney, and all my stuff is in there, nice and clean. Or I'm going to print both of these out on a giant printer plotter for work, for some machinists to make the part. everything is very simple to do with Fusion 360 for CAD drawing. Let's go ahead and dive in and actually start making these parts, and it'll make more sense how we were able to easily import these parts for the viewing of the design.
All right, we're going to go ahead and jump in here. At the bottom right, you see the mouse icon. When I hit the middle mouse button, you'll see the middle mouse button covered in red. If I hit the right click or left click, same thing. And then the keys that we're going to be using quite often, you'll also see that when I click a particular key, you'll see it highlighted in red. So now we'll go ahead and get started here. All right, so one of the first things we're going to do is come up here to document settings, set our project into inches. Maybe I'm usually in millimeter. I do a lot of millimeter design work. And click OK. We're going to click this little eyeball here by the origin so we can see the origin. You'll see it appear and disappear. We want to be able to see that. And we'll go ahead and start by making a circle by hitting the C key for circle. We'll click on this plane. We'll make a circle here. And maybe you want a 2-inch circle. So you can hit the enter key to kind of input things. So we'll redo that. If I hit the C key for a circle and I bring it out here, I can hit the number 2 for 2 inches, and I can hit my enter key. So let's see. Yeah, anytime I hit the enter key, it's right there in red, just so you see it, because I use that quite a bit. It speeds up design. Let's go ahead and make this 0.5 inch. And using the middle mouse button over at the bottom right, you can see my zooming and scrolling at the bottom right. If I hold down the shift key and I hold down the middle mouse button both, I can do this rotational action. I can also come up here and rotate. Let me get my beautiful face out the screen here. If I hold the shift key and the middle mouse button, I can rotate. And if I just hold the middle mouse button, I can pan back and forth, left and right. And I can come up here and I can just left click and hold the mouse button and rotate the screen here. And if I do one single click on the axis, it will snap to the front. So down here where we have display, let's go ahead and go to visual style. Make sure you're set shaded with visible edges only. Okay, so we have the circle here, and maybe you felt like you jacked up. We'll go ahead and redo it. You can click on the circle, hit the T key. So the T key is for trimming. So we typically trim or dimension a sketch line. So think of Donald Trump. Donald Trump for dimension and trim. So we'll hit the circle key which is the C key. You can also get to the circle by hitting the S key. So the S key is your search key. So we're going to find a lot of your stuff. The S key speeds everything up from having to come up here and hunt through stuff and, getting up here. And maybe it's easier for you to come up here and click center diameter circle and then drag it out and do a 0.5 inch. But I find it easier to hit your C key for circle and then drag it out, do 0.5 inches. Okay, now we're going to do a center rectangle. So you're going to notice a pattern here. This little sketch shortcuts pops up a lot because I use this instead of all this up here, because a lot of this stuff up here, you probably never use it. We will cover over constraints, but not a whole lot here in this video. So what we want to do, let's create a center rectangle. So when I hit the S key for search, I can type in center rectangle, and there I find it. And anything that you want in your shortcuts that you're going to use a lot, whenever you are searching for it, if you know you're going to use center circle and center rectangle quite a bit. So whenever you find it, you'll notice that there's a little up arrow key, and that adds it into your shortcut. So you can just quickly do this right here and select the most used tools that you build in your little toolbox. So you don't have to type and search for them each and every time. So I'm going to use center rectangle, and we'll snap to the center here, and we'll just make some kind of little box here. I'll hit my escape key, and I think I want to make this 0.125, and now we're going to hit the E key for extrude. To turn this drawing into a 3D object, we're going to do 1/2 inch thick and hit the enter key. So I'm holding my shift and mouse button around, look at that. Okay. Now, when we did this, when we hit the E key, let's back it up by holding Control and hitting our Z. While holding Control and hitting Z is our undo. So if we screw up and we need to undo it, hold Control and hit Z. Standard keyboard shortcuts. I'm gonna go back to 1.5. Okay, so I hit my E key for extrude. I want to extrude this right here. Up here I have different options. If I'm doing a cut, a join, intersect, new body. I just want to do a join, so I'm creating extrude. You can drag this little arm to the size you want. I'm just going to type 0.5 for 0.5 inches. And now I want to make another body. So maybe I want to make another rectangle bracket. I can hit the R key for rectangle. And maybe I want to snap this way. Maybe I hit the. If you notice, I hit the escape key to escape out of something I'm doing. I want to snap this to that and make it the same size. Now I'm going to hit my E key to extrude this out. But I want this to be also 0.5 inches. But I don't want it to join. I don't want to join this box to that box. If I do that, let's say I click OK. Now it's all in one piece. I'm going to hit my Control and then my Z key to go back to undo that. I'm going to hit my E key to extrude. I'm going to extrude 0.5 inches here. And let's create a new body. And then we'll click OK. So now, if we come up here, we have bodies and a little drop down. And we have the different bodies. So now we can do stuff. Like I can hit the M key for moving. So if I come over here and I hit the M key, like as in move, I can move this thing around now. I can do stuff to it. Okay. I'll go ahead and click cancel here. Maybe I don't want to move that quite yet. And we're going to go ahead and just cover over bodies and 3D printing, plasma cutting, laser cutting, or water jet cutting. So over here, maybe I want to, I just want to get a profile of this part right here. I want to water jet cut it, laser cut it, or plasma cut it. So those three technologies pretty much will use a DXF file. So anytime that I want to maybe make a DXF, I like to use the P key for project. I'll hit the P key, I'll click the face here, and then I'll click OK. And you'll also get this like purple reddish outline going around it. Let's say I hide this body. Now you'll see that I have this purple reddish outline, and click finish sketch. So if we come over here to sketches and we click the drop down, here's a lot of the sketches that we've created. And this one with the little red lock key on it is a projected sketch. I can hide it and show it. All the little eyeballs just hide and make things visible and invisible. I'm going to left click on it one time, and then I'm going to left click on it a second time to rename it. I'll call this water plasma laser DXF. Okay, so this can be water jet cut, plasma cut, or laser cut. And the way we're going to do that is we're going to click on it, we're going to right click on it, and save as DXF. Very straight to the point, and cut this to 2D. You can give it any name you want. And then the type is going to be DXF always. And then you click right here to save it in your computer where you want to save it at. And I'll keep it called cut this 2D file. I'll click save. And then I'll click save again. And now you can take that cut file that you saved in your folder and go put it on your machine and cut this profile here. So I'm going to hide that, and I'm going to bring back the body here, and I'm going to bring back this body. So let's do some stuff here. Maybe we want to cut this block out of that block, but first, maybe this block needs rounded corners. So we'll hit our F key for a fillet, which some CAD software calls it a rounded corner. A fillet, rounded, or rounded corner can be interchangeable. Maybe I want to click that edge, and I want to click that edge, and I want to give them a 0.5, oops. See how that kind of went Picasso on us real quick? Maybe I want to give a 0.125 radius. I'll hit the Enter key. And let's see something. Okay, so we've got our radius here, and we can hit the F key again, and we can select some more edges. Maybe we want these radius as well, and we can keep them any radius. Maybe we want to do this one, that one, and look how I don't have to turn it. I can just see through it, and the software's smart enough to know there's a line right there. Now I can do all 4 corners at one time. Click OK. But let's cut this block. Let's cut this block into that block. The way we'll do that is we'll come up here to combine, and we're gonna say this is the body, the target body that we want to cut out, and the tool body. We'll click this body here, and we can do a cut operation. But right now, if we were to cut that out of that, it would do nothing because we need to move this. So let's come over here to body 2. We'll hit our M key to move it, and we'll move it in a little bit. However much doesn't matter for the tutorial. We'll click OK. So now you can see this model is stuck into this model. Now we can go ahead and do a combine, and we can do a combine of 2 types. We can say join together and become one new part, or we can say I want the tool body to cut out of the target body, and we have this little option to keep the tools. If I don't select this option, the tool body will disappear. So we'll click OK. So now we don't have the tool body. So maybe we're just using that temporarily to make a cut. But down here in your timeline, this is where we can go and edit previous steps that we've done before. So I'm going to go ahead and go back to that combine. I'm going to double click it. But this time I want to keep the tool that I'm using to cut out of the other object. I'm going to click OK. So now you can see here, you got this tool. But in a computer world, they're perfectly, slotted together with beyond micron precision. But if we were going to machine this, we need to have a little bit of tolerance. So let's hide this body from that one. Let's hit our S key, and we're going to type in offset. And you're going to find the icon that looks like this one right here. I'm going to click it, and I want to click on this face right here. And I'm going to click this this line here. And maybe I want to offset, maybe, let's say, we'll do 5 thousandths tolerance offset. And I'll hit the Enter key. You'll notice that I use this Enter key on the right of the numpad quite a bit here, the one that keeps blinking in red whenever I type something in. Now we're going to hit our E key for extrude. We're going to click this outer line right here. We're going to come up here to distance, and we're going to click to object, and we want to click to this face, and it cuts it out. So we'll click OK. Now if we bring this body back right here, we can see that we have a little bit of gap in there. So this part can fit into that part whenever we machine it. So that's how you can do a binary cut option. A lot of CAD software calls it a binary cut, like Blender or modeling, or a combine, or combine cut. And another cool thing is if we ever need to ever change anything, we can just come back here and make a change in our timeline. So let's look at the bottom down here. What are we looking at? Typically you have sketches and features, so a drawing and a thing you've done to the drawing. So these little icons here that look like little drawing with little tiny pencils on them, these are your sketches. And so you can always come back in, you can always make an edit to a sketch that you're wanting. So maybe I didn't want to hide this body here. Maybe I wanted to change that to something else. Maybe I wanted it 10 thousandths tolerance. Then I can hit the enter key there and click finish. It'll parametrically make the change. So now we have a lot more gap in there. You can see that down here. But when your assemblies are getting very big, and you look at your timeline down here, and you have hundreds of these, sometimes they're hard to find exactly what you changed and where. And an easy way to find that is you can simply click on an area where you made a cut. Maybe I want to know where in my timeline did I cut into that wall. So when I click on it, you'll notice down here is 3 little dots. Above the feature, remember, we have a sketch and what we've done to the sketch, which is a feature. In this case, it was an extrude cut. So I can also right-click on it, and I can go back to Edit Profile Sketch. So if I click on that, it brings us back to the sketch that was responsible for the feature that cut that face out. So these are huge things to get up and running pretty quick with Fusion 360. Now, let's say this is a part you need to machine. We can, maybe you got to send this over to a company to machine it out for you. You can export it by clicking on File, Export, and go to Step Files is a common export. You can also export it as a STL. Maybe you're going to 3D print it because you're prototyping it first. So you can export that as an STL file. I'll show you a different way that I normally export my STL files, which is much faster. But a step file is going to be a quite common one that you're going to do. And then there's some other, you got DWG files. You have some other file types in here. But typically you'll be exporting as a step or STL, or maybe you're actually going to send this to another Fusion 360 user. You'll use this option right here, Autodesk Fusion Archive, which is a .f3d project file, and you can send that .f3d to another Fusion user, and they can open your project in Fusion, and they'll get all your timeline features and everything you've done to that part. So that's how you can export your parts for machining. And you can always come up here to design, and you can go to manufacturing, and you can start setting up a machine. So you can start doing CNC machining with a Haas machine, or different, pretty much any kind of machine that will have a post processor that you. Another thing we will go ahead and jump on over to is drawing. So you can do you can take your design here, and we can move over to drawing, and we can go from design, and we'll call this CAD drawing, GDT. We'll click save here, and by clicking CAD drawing, we can go ahead and we'll click automatic mode for creating a drawing from design, and we can just click OK here. We're going to move over to a CAD drawing actually is pretty much creating one for us. Let's go over to drawing. We'll go back to design. We'll go to manual. We'll click OK. And we can set our orientation. And let's say we want our part, right? Boom. And maybe we want this in an isometric form. We want to show that right there. We can come over here in our bodies. We can bring back this body if we want. We can include that into the drawing. And we can also, drag this body right here. Oops. Show high. Maybe I want to create we'll say a base view. And I'll click right here. And we'll click, and we'll keep it straight like that. And then maybe I want to edit that guy. Edit view. Maybe I want it to be solid. Instead of I want it to look like a solid body. And maybe I want it to be, can add a little bit of contour to the design. I want to show my center cuts for GDT, center lines, and so forth. And you can play with these different options around here for what you'll think you'll need. I want to show my rounded fillets. Maybe I want to scale it up to, or I want to, I want to do a 3:1 scale. I want to make it a little bit bigger so you can see it better. And maybe this one, maybe we want this one here to be, we can go right side. Basically, you can change the orientation around here. Maybe we want it to look like that. Then go ahead and click on close. Maybe we want to draw this here. Maybe we want to not show that part. Or maybe we only want to show that part. And then we can go back in here, edit view by right clicking. And maybe we don't want it that big. Maybe we just want it to be 2:1. We can hit our enter key. I'll draw this guy up here. Maybe we need to do a base view for standard CAD drawing, right? And take a note down here. We can always change this stuff to let's see, strut to right hand aft. Whatever the project or part name is, you can put the part name in there. Or again, if you want to have a project, maybe GDT drawings, and you can kind of pretty much go in here and edit pretty much everything you want. Maybe I want to add some text here. And maybe I want, point X to be 0.0. Maybe I want that one to be 30 thousandths tolerance. And the point XX to be 0.050 thousandths tolerance. Maybe XXX here needs to be 0.0 5 thousandths tolerance. And then, you you can pretty much edit all this stuff as you so want. We'll zoom out here. And actually, let's go back. Maybe maybe you can always finesse this, add it, make it look nicer. Here's your revision number, so maybe I want to put a revision number here. And then, revision 3. And then maybe I want to do a date, 12/23/24, and that one. Maybe we'll do 15/35. Put your time in there, whatever you want, whatever you wish. So you have a revision time here. And then let's come back up here and let's do we're going to do a projected view. Oops. Spectral views of the oops, we need to get rid of projected view. You got breaks and things like that where you can put a break into something. You can break your part, let's say you got a really long part. We'll go ahead and undo that because that doesn't make sense for such a short part. But up here, let's go ahead and go back to a base view. We'll put it in the center here. And maybe we'll do a 3:1. And let's do, we'll do visible and hidden edges. And now let's start putting some geometry in here. Maybe we want to do click auto dimension, which you'll find in like Solid Edge and a lot of other CAD. Maybe I want to snap some auto dimensions really fast, right? Boom. There's our radius on the circle, and there's a radius on our corners here. Just real quick and fast, right? Just right to the point. Saves a ton of time. Maybe I don't want that. Maybe I want to, maybe I want to be very particular about something. So maybe I want just a radius here. Maybe I just want this radius here, or this radius here, and so forth. So at this point, you kind of get the point here. You can put tables whenever I'm sending over a mold to China to have them injection mold things. I look at their data sheet, and then I'll create a table on my CAD drawing on the part, and I'll give some tolerances and material type and material data to provide the information that they're asking of me. Oops, got a strong bright light here. But this CAD drawing right here can quickly and easily be exported out. Export to PDF, all sheets, or current sheet, or a range of sheets. Maybe have a multiples, and the way you add more sheets is down here. If I want to add another sheet, I can create 2 sheets, and I can toggle between them down here. I can also delete it by right-clicking and click Delete Sheet. So right here, in just a few minutes, you've learned how to do a CAD drawing. We're going to go ahead and end the video here, and we'll pick up more later on as we continue on. So I'm going to go ahead and close this out right here. I'm going to go ahead and save my CAD drawing into my project. And anytime you need to get to your CAD drawings, when you click on this little project panel here, and it loads up, which I'm running a ton of video editing software right now, and CAD on top. So this thing is not wanting to negotiate with me. Look at all, I got Adobe running in the background. I've got a ton of video editing software as well as live streaming software. You go ahead and we're refactoring the design mode here. So I can click save here. Now let's go ahead and cover over some joint operations, so joining. So let's bring our other body back, and let's say for whatever reason we want to be able to make an assembly here. We'll cover over assemblies real quick. I'm gonna click on this body, and I'm gonna hit the M key for move. I'm gonna move this over here, just out the way. I'll click OK. But we cannot join bodies together. We cannot align bodies. So if we hit the S key and we type in align, we can now come over and pick a point on our model. And if we hold the control key down, notice the little red on the control in the bottom left of the video here, we can select the point. If I want to align the center of that hole to the center of this hole, be sure to hold your control key down. Sometimes you don't have to hold your control key. You can just hover your mouse over it. But if you notice how that wants to disappear on you sometimes, when you put your mouse over a face, if you hold the control key, it keeps all the points locked, so they don't vanish on you. I'll click OK right there. I'll click OK. And now we have essentially aligned this part with that part. But we can still move things. We can rotate this. Again, to move, we come up here and we click on the body and we hit our M key to move. We can rotate it. We can move it around in space very easily. We can do all this stuff. But to join this to that, we need to turn these into components. So to do them all at once, hold your shift key down. So you look at the shift at the bottom left. Oops, oh, don't want to do that. Hold your shift key down and select the range of bodies that you want to turn the components. Right click on them, click on create components from bodies. So now these are components. With components, we can build an assembly, because an assembly is just an assembly of components. Now we'll hit the J key for joint, not that kind of joint. And we'll come over here and we'll zoom in. We get the same kind of little option we see with the align key, but there's differences here. We'll hold the control key and we'll click the center of that. And we'll come over here. We'll hold our control key and we'll click the center of that. But the type of motion that we pick here is quite important to your joint. If we do rigid, it's kind of like we're welding that part to that part. So we can go back to position. We can toggle between these two. Maybe I want it to be rigid right there. Maybe we're going to have some range of motion this part is supposed to have in relationship to this part. So if I want it to be kind of welded together where it's technically never going to be moving around, like especially if I'm planning on animating this, like if I'm going to animate this to look at the mechanics of it in the future, then I might want it to be able to move. So in that case, if I want it to move, I can come to motion, in the type of motion, and I can do cylindrical. And you'll see kind of the axis in which it's going to move. So at this point, it looks like it would move as a rigid would, but we'll find the difference. If I come over here and I go to motion and I click rigid and I click OK, now if I come over to component 1 and I hit my oops, I right click on it and I click move type, if I click bodies and I move this, well, it'll let me move it. That's not supposed to. Essentially, this joint right here means that if I try to move this, it's not going to let me move it. It's pretty much rigid fixed. If we come back down to our timeline down here, and I right click on it, or I'm sorry, if I come down to the little joint operation in our timeline, and if I double click on that, and we change the motion to cylindrical, and I click OK here, I could give that thing limits. So if we want to get real complex with it, I could give a minimum and maximum motion limit to what it's allowed to move. That can then, preview the movability of the object. Maybe I'm designing, a bearing or something like that, and I have a drive system going through 2 parts. So I'm going to leave that. I'll click OK. Now if I come over here and I click the M key for move, oops, I'll grab this little square here, and now it's going to move for me. Where when it was rigid, it didn't want to give me the option to move. So maybe I want it to be able to swing this far right here. I'll click OK, and I'm going to do a combine, capture position. I want to combine this with that, but I want to do another cut, and I want to keep the bodies. So I'll click OK. And now if I want to move this again, now you can see that we've made this cut. So whenever this part is moving, if we were to machine this out, it's always going to stop right there because we're kind of cut in a little block there. And we can kind of give our rotational limits by doing the same process. So maybe I want the maximum rotation from this end here to stop right here before it hits this metal and gets stopped. Or maybe right here we're putting a switch for a machine we're designing that's computer controlled, and we're looking for a limit switch to get hit right here. So we'd have a little switch we design. So we're going to click combine, capture position. We're going to click that. We're going to click this body. And you'll notice that Fusion was smart enough to know that we keep using this keep tools option. So it automatically checked it for us. But you always want to double check. I'll click OK. Now I can click on this component, hit the M key again, and I can rotate it back. Now you notice this little edge right here has been cut. And so we have our limits in there. So we'll go ahead and pretty much stop this here, other than we really need to cover some basic dimension stuff. So the D&T, Donald Trump, and we'll finish out this video with the D&T concept. So let me hide both of these here, and we'll start. Let me hide the joints so the cops can't come and find it. Hide the joints. We're going to click on this face here, and we'll click on our R for a rectangle, and it can just snap a rectangle. And you'll notice here, if I hit the Control and Z key, I'm undoing. When I snap a rectangle, I can get options there of how. Control and RZ, or Control Z. If I hold my mouse button and I want to type something in, I can, maybe I want to do 1 inch by 1 inch, and I let it go. I can toggle between these two right here to set dimension. Right now I want 3 inches by 1.5, and I hit the enter key. If I hit the C key and I do a circle, everything can be dimensioned later by hitting the D key. So that's our dimension key. So let's come back and just make a rectangle real quick and fast, make a circle real quick and fast. Okay, we don't have to worry about the dimensions, but maybe I want the center of this circle 0.125 inches away. No, that don't look good. Maybe I want that 0.5 inches away, and maybe I want it also 0.5 inches below the top, and maybe I want this to be 1.5 inches tall by we'll just say 3.5 inches long. And if I hit the L key for a line and I move this mouse across this line down here, you'll see I get a little triangle right here in the middle. So now I have a center point. I can draw a line, and if you notice, if you hit the tab key, the tab key pretty much switches between your two parameters here for how long I want that line and at what angle. So let's say we know we want a perfect 90. Let's say I'm having problems getting that 90. I can tab over, I can type in 90, and now no matter what I do with the mouse, it won't swing. It'll stay locked on 90. See that little lock key next to the number 90? So maybe I want to click right there, and I'm going to click this little check mark. And what we're going to do is a mirror option. I want to mirror this circle to this side perfectly. Well, we don't have a dimension on the circle. How big is it? We don't know. Let's click the D key for dimension, and it's 0.79. Let's do 0.75, right? 3/4 inch. Now we're going to hit the S key, and we're going to type in mirror. We're going to click on our mirror icon, and I want to click this circle, and up here I get this little menu box. I want to click mirror line, and I want to click across that line. And click OK. So now I have two circles that are symmetric on this part. They are perfectly distant in all fashions. So this circle is exactly 1/2 inch down from the top, and we can check that. Let's go ahead and hide the origin here so I get that out of our visibility. If I hit the D key for dimension and I click this right here, you can tell that we're already 0.5, and it's warning us that the dimensions are overstrained because it was copying all these dimensions that we created onto this circle when we did our mirror feature, or when we did our mirroring. So, but you can over constrain them anyways, just in case you want to see it. I can hit my D key and select the center of that and that. Create driven. I can't move it because it's locked in place through the black lines. Everything's locked in place when you have black lines. And then maybe I want this to be, we'll say, from there to there. Create driven. Because it's not going to let me change these because we're copying from this side. But for visibility, maybe you want to be able to see that. So here we'll go ahead and end it because this pretty much really covers a lot of the basic things you're going to use onto more advanced stuff. But it'll get you jumping in and running with Fusion 360 in a more commercial, productive environment.